So, welcome everyone. Glad to be here in Nuremberg, SPS IPC Drives. MindSphere Lounge is very busy, and since we're in the MindSphere Lounge, I wanted to provide a little bit of context. So the context for this talk clearly is MindSphere and the Internet of Things. So IoT is the topic, and the relevant component of the ecosystem that I wanted to talk about is the IoT framework from Mentor Graphics. So the IoT framework is the relevant product that allows you to connect a variety of operating systems to the cloud, so to MindSphere. We're very excited about the MindSphere 3.0 announcements. We're looking forward to that. And allows you to connect into all major IoT protocols. So MQTT and all of the rest of them, OPC UA in industrial settings, as well as end-to-end security for the platform, for connectivity, and also for the tools. So my colleague Scott Morrison gave a talk yesterday about securing your embedded devices and securing IoT. I urge you to go and watch his presentation if you'd like more information about security. Our framework also scales from resource-constrained low-cost microcontrollers, all the way up to high-end multi-core processors as you see it in applications. So what we're talking about in the context here are things like the edge and end nodes that you would see on a factory floor, for example. And like I said before, we're operating system independent. So we've got a couple here. The Nucleus RTOS is our real-time operating system, and then we have our Linux offering there in Mentor Embedded Linux. But we also support other operating systems as well, because we feel it's important to provide this IoT framework, which, like I said, not just connects you to the MindSphere ecosystem, but allows you to provide updates so that you can either roll out features for your devices, or also mitigate security vulnerabilities. So it's important to keep your devices patched. This is one method for distributing those kinds of changes to your devices. The topic of this talk, though, is really about the left-hand side here. So this component on the left is the Sorcery Codebench development and analysis tools, and specifically Sorcery Analyzer. So Sorcery Analyzer is a trace and visualize design analysis solution. So this allows you to combine profiling with an analysis engine to visualize the behavior of the system at a very deep level. So just a few details there. I'll go into more detail later, but you can extract, say, for example, CPU usage or kernel events. You can use locking patterns. Look at concurrent race condition type problems, finding memory leaks. These are all very traditional software engineering, especially in the embedded systems development sphere. And with all of that data, it's difficult to look at in sort of table form. So what we do is we provide easy and intuitive visualizations of each of those things. So you can see two of these here. On the left-hand side is more of a system view, and on the right-hand side is a little bit more of a physical measurement of the system. So, and with that, you can also integrate custom analysis of your own application layer. So it's not just kernel information, but it's specifically about the application that runs on the edge or end node. And like I said, analyzing behavior for performance optimizations on either unicore or multi-core systems. It's important to provide a little more context here. So everyone who's been walking around the MindSphere Lounge has already seen a number of analytics dashboards. It seems like that's the number one thing that you see on almost every station here. And a lot of times that telemetry data really tells you about the physical world around the device. This is a physical measurement type of information for decision making. What we're providing in addition to these types of information is the much deeper dive into the embedded system information. So the kernel and application layer on the device itself. So it's more about the state of the device versus the state of the world around the device. And so just to go a little deeper on Source-Free Analyzer, again, this is a trace and visualize tool for operating system and applications. And we're looking to address things like race conditions and latencies, bugs that don't cause traps. But really, it's where systems, where you can't really stop the system, analyze it, right? Take a core dump, for example, and analyze it that way. It's just not possible in a lot of these production systems after they've been deployed. So what you'd really like is the ability to trace these systems after they've been deployed. If they misbehave, they're not working exactly as designed, you want to find out why. So that's exactly a perfect use case for Source-Free Analyzer. And you can do it, like I said, at the application or at the platform level. The view on the right-hand side is a blown-up view. I'll go through it in a little bit of detail here. There's 8 CPUs. Those are the top gray lines here. And each of these bars shows you the state of each of those CPUs at a given point in time. Now, we've zoomed in very closely here on a very short timeline. So the distance between the green lines here is, for example, 1.5 milliseconds. So it's a very high level of detail for extracting behavior of multi-core systems and finding things like race conditions, for example. After the CPUs, we have a number of traps, and the soft IRQ, for example, is used in, say, Linux for trapping and interrupting the various processes on a system. And below that, you would have process and thread state and a number of other embedded system variables that are important for optimization of the system. And like I said, we have application awareness, and then, of course, you always have the historical log archive, so you can always go back and see, well, how did it work previously? How does it work today? What changed? And here's a few more views. It goes over some of the pieces that I talked about previously, but like I said, single and multi-core visualization and analysis. We have power and performance analysis. So I know power consumption can be important. Some of these devices shed a lot of heat, and so if you're not doing power management correctly, now you're pulling more power, and these are things important in certain settings. With both of these, we have integration with Nucleus and with our MEL, Mentor Embedded Linux. So some of the views that you see on the right-hand side include process and thread state. This here is a Gantt chart showing you top 5 functions by time. So where are you spending most of your time? You can find out where you really need to spend your time as a software developer to make things go faster, or find out where you're stopping for no good reason. This view here is a statistical view of where you're spending your time in each CPU. So if you have, for example, a scheduling problem, or you're not taking advantage of all of your cores, it becomes very, very visible in these kinds of graphs and visualizations. Here's a signal monitoring example. So on the left-hand side, you have an inverted pendulum. So this is a really common, almost a college-level project, but it's useful because it brings in 2 different worlds. You have the physical measurements, things like the tilt angle, the wheel position, and really you're trying to keep this inverted pendulum upright and moving. And on the right-hand side, you can see the Source-Free Analyzer instrumentation of the physical characteristics of this system. So you can see the wheel position changing over time, and even though the position drifts, the balance has to continue to adjust there. This is really a PID controller in action. So how does this play into the cloud? So we've heard earlier this week about how we're now in the age of the implementation, and so Analyzer is no different. Traditionally, in the past, what we've seen and what we've done is with embedded software development, it's always been an engineer's workstation and then the development device on the same table, usually. But now, what we're doing is we're bringing the power of Sorcery Analyzer into the cloud. The way we do that is the engineer would still have their engineering workstation, but possibly the edge or end node device, like this IoT 2020 Semantic device from Siemens, that could be deployed already. This could be post-development, post-deployment. The engineer would send a signal to, say, MindSphere, which would then communicate with the IoT device, indicate a trace has been requested. So the trace is then captured, then uploaded to the cloud. The signal comes back to our application, Sorcery Analyzer, and all that data is then pulled back in for all of the visualization capabilities and all the optimization capabilities. And this ties back into the first slide that I had. So the IoT framework would then allow the developer to push whatever update they needed to optimize their edge and end node devices. And so that the ability to update your end system would come from something like the IoT framework. So I do invite you to visit us. We are over in the MindSphere Lounge with a demonstration of both Sorcery Analyzer and the Mentor Embedded IoT framework. And to learn more, visit us on the web at mentor.com/embedded. Thank you very much.